Hello friends, in previous videos we derived different power gain, that is operating power gain, transducer power gain and available power gain. In this video we are going to solve the problems on these power gains. Let's see example number 1. Before that, first we summarize the formula to be used for amplifier power gain. First is transducer power gain. So this is the formula for transducer power gain. For operating power gain, we do one thing, keep the second part, that is mod S21 square and 1 minus mod gamma L square divided by 1 minus S22 gamma L mod square, keep it as usual. Only change the first term by 1 divided by 1 minus gamma in square. Now available power gain, keep two first term same and replace last term by 1 divided by 1 minus mod gamma output square. Yes, if you know the transducer power gain formula, then you can easily write operating power gain and available power gain formula. You will see three cases of an amplifier power gain. So case 1, matched transducer power gain. So we know the formula of transducer power gain. So this is the formula of transducer power gain. Matched is nothing but no reflection occurs at input as well as output. So we put gamma S equal to gamma L equal to 0. Put gamma S and gamma L in this equation, then first term becomes a 0. At the same time, second term also becomes a 0. Then it is then only one term has remained, that is a mod gamma mod S21 square. So right here, match transducer power gain is equal to S21 square. For second case, unilateral transducer power gain, unilateral device is put S12 equal to 0 and in this formula. For case 3, maximum unilateral transducer power gain, we know for unilateral power device, it is S12 equal to 0 and replace gamma S equal to complex conjugate of S11 and gamma L equal to complex conjugate of S22. Put into this equation, then equation becomes 1 divided by 1 minus S11 multiplied by complex conjugate of S11 is a mod S11 square. So this is a mod S11 square. Then S21 square as usual, and second part 1 divided by 1 minus, replace gamma L by complex conjugate of S22. Then answer is 1 minus mod S22 square. So these are the formula to be used for matched transducer power gain, unilateral transducer power gain and maximum unilateral transducer power gain. Let's see the example. The scattering parameters of microamplifier are found at 2 GHz as follows. Z0 equal to 50 ohm, S11 is 0.97 angle minus 43 degree, S12 is 0 means it is a unilateral again. Then S21 equal to 3.39 angle 14 degree, S22 0.63 angle minus 32 degree. The source and load reflection coefficient, they are given gamma S and gamma L respectively. Determine transducer power gain, available power gain and operating power gain. First, write given data. Here given F equal to 2 GHz. Second term Z0 equal to 50 ohm. S11 equal to 0.97 angle minus 43 degree. Then S12 equal to 0. S21 equal to 3.39 angle 14 degree, S22 equal to 0.63 angle minus 32 degree, gamma S equal to 0.97 angle 43 degree, and gamma L equal to 0.63 angle 32 degree. So first is a transducer power gain. We use this formula, then put all the values of gamma S, S11, gamma L, S22 and S21 in the above equation. Then you will get an answer that is T22.42. Same part, we calculate operating power gain. For operating power gain, this is a GP equal to, replace first term by 1 divided by 1 minus gamma n square. Put all the values in the equation of power gain, then you will get answer. It is a P22.42. Same part, we will calculate available power gain GA equal to, now keep two term as usual, replace last term by 1 divided by 1 minus gamma output square. So from a given data, put all the values in the above equation. When you put all the value above equation, do the calculation, then you will get an answer. This is a P22.42. From above, we find that GA equal to GTU and available power gain, then transducer power gain, and next part is a gain of operating power gain. So right here, operating power gain. So all are equal because of unilateral. Unilateral where gamma in equal to complex conjugate of gamma S and gamma output equal to complex conjugate of gamma F. If you see here in a given data, here this is a gamma in, it is 0.97 angle minus 43 degree, and here you see here it is 0.97 angle 43 degree, meaning is that gamma gamma in is a complex conjugate of gamma S, and second term S22 0.63 angle minus 32 degree, gamma L is a 0.63 angle 32 degree. So what is it? Gamma out equal to gamma L complex conjugate. So because of this condition, we will get all power gain has a same value, that is 3.322.42. Thank you.